Okay, the next topic that we're going to look at is with radicals and fractional exponents. We're going to see the relationship between them and then how we can actually use that relationship to simplify expressions involving radicals. So first, recall now we were in the previous section simplifying radicals. We had the nth root of x to the m, and we found what we were doing was actually dividing the root n into the exponent m. And so if we wrote that out, we could say then that the nth root of x to the m is the same as writing x to the m over n. Now we can use that to take a radical, like for example square root of x, which we could rewrite as second root of x to the first. And we'd use this relationship to write square root of x using fractional exponents. That would be x to the 1/2. As another example, consider cube root of x squared. Again, it's x to the m over n, in this case x to the 2/3. Or as a third example, what about fifth root of x squared? That would be x to the 2/5. One final example, what about fourth root of x squared? Well, that could be written as x to the 2/4. But now you see 2/4, that fraction can be simplified, so that's actually x to the 1/2. This is the one time that I had mentioned before where typically if the thing inside, the exponent inside the radical is smaller than the root you're taking, you can't really simplify. The one exception would be when that thing, when you write it as a fraction, if there's a common factor that could be divided out. So in that case, fourth root of x squared actually can be simplified to be x to the 1/2, which we could then, if we wanted to, rewrite as square root of x. Okay, we could go the other way as well. If you had a fractional exponent like x to 3/8, we could rewrite that as a radical. That would be 8th root of x cubed. As another example, if we had x to the 1/3, we would rewrite that as third root of x. Or one final example, x to the 7/4 could be written as fourth root of x to the 7th. But hold on to that fourth root of x to the 7th for a moment, because in the last section we talked about simplifying that. So we could take out a x to the 4th, because 4 will go into 4. So we could rewrite that as fourth root of x to the 4th, fourth root of x cubed. And then simplify fourth root of x to the 4th by division. That would just be x, and then the fourth root of x cubed is left over. Now the biggest problem that most students will have with this idea is getting that fraction backwards and doing n over m. So something to help you remember that is that if you think in real life, where do you find roots? Well, you find roots in the ground. So the root that you're taking, it grows in the ground, or in other words, the root that you're taking is going to be in the denominator or the ground of the fraction. Okay, roots grow in the ground. Okay, roots grow in the ground. Be careful if you're ever doing this kind of math in a cave, because then you might get a little confused, because when you're in a cave, roots aren't in the ground, they're in the ceiling. Then you might get this backwards. Or not, you might just get a really bad joke. So roots go in the ground, so the root we're taking becomes the denominator, and then of course the other thing would have to be the numerator. So using that idea, hopefully you can keep this straight. In upcoming videos, we're going to review our properties of exponents, dealing with some problems with simplifying problems with fractional exponents, and also with radicals. Until then.